So, for homework yesterday, it's the same thing as today because we did not finish the lesson and it's a combined homework assignment. So, if you look over on the homework board, that assignment is due the 13th at midnight, right? So that's Tuesday of next week. It is due by midnight Tuesday. So on Monday, you should be bringing questions to class. And actually, we did not get a chance yesterday to talk about a couple questions from the 5-1, 5-2 practice. So if you're still struggling, by the way, if you're watching the video, that's the rest of that little picture there. Pretty cool. We're going to slide that back up onto the homework board. So, if it opens, so the last two problems on 5-1, 5-2 are very, very interesting. And interesting to the point that you might argue with your parents. So, and this is the funny part about the math. So, one of your peers actually called me. He's like, Mr. Hudson, my dad is telling me that I'm wrong. But Schoology, the assignment, is telling my dad that he's wrong. And my dad is telling me that the assignment is wrong. I said, well, I understand why your dad is thinking what he's thinking. And actually, even back when I was in school, this would have been a mistake that somebody could make. So, this problem right here, problem 17 from your 5-1, 5-2 homework. How would you read that like this? How would you read that? Yeah, Sarah? But is the negative attached to the 5? Like, are they grouped together? Are they grouped in a parentheses? So, here's the part that I will admit is tricky. It's a tricky part of this. This is the opposite of 5 cubed. Because according to the order of operations, my exponents happen, and then further down the line, my arithmetic happens, and that's the minus, or the negative, or the opposite. Now, here's what your parents are thinking and remembering. They're remembering that this number is -5, and it's being raised to the third power. That's not true. That was wrong when they learned it. For that to be actually -5 to the third power, it needs to be grouped in parentheses. So this actually does 5 times 5 times 5. That's your 5 to the third power. Then the opposite happens. 5 times 5 times 5 is 125. And then I put the opposite on, and I get -125. Now here's where this gets even worse. Oh no! If you typed in -5 to the third power, you would get the same answer. Because values to an odd power that start negative stay negative. Because this would be -5 times -5 times -5. 3 negatives. These two would pair up and cancel each other out, but this one would keep it negative. Now, number 18 is different, though. Josh? No, this is the homework assignment. I just made it into a PDF. But these are questions 17, 18 off your 5-1, 5-2 assignment. Yeah, so if you already... Oh, that capture's not going to work good. Give me a second. Do it again. I didn't realize it had not. So, on 18, if we read this accurately again, this is the opposite of 10 squared plus 4. And guys, this is me telling you there will be questions identical to this on your mastery. This is why I'm reviewing this right now, because I know people struggled with this. So, this is the opposite of 10 squared, then plus 4. The exponent has to happen first. So, what's 10 squared? Anybody? 100, right? Because it's just 10 times 10. So, this becomes the opposite of 100 plus 4. Brady, you've had your hand up. Question or answer? What is it? Negative plus a positive. Which one's more powerful? The negative wins. And the difference between them is 96. So, if you want to blow your parents away, like knock them over on the floor. They might pull out their wallet and just give you money.
I'll do that.
If you are discussing this problem with them, what you need to remind them is the exponential operation comes before the arithmetic operation. So if you think about the order of operations, the exponential comes before the arithmetic. Arithmetic or arithmetic just means add and subtract. It's like the easy math, the add and subtract. So arithmetic or arithmetic operations, those are last. So be careful. Why?
I know. I saw that change. I just didn't want to say anything.
Yeah.
I didn't know if you did it on purpose.
No, I just kind of did it. I think it did it when I tried to capture it, something like that. Any other questions off the 5152 homework that I believe I've now made due Sunday night? The due dates are accurate on Schoology, so check it out. But I think it's due Sunday night. You guys should have it done, but yeah, Zion. Yeah, sweet. Do you have questions over it?
No, I didn't know we weren't supposed to do it yet.
We were supposed to.
You were supposed to do it.
Oh, so
It's been open for you to do for a while, because we started 5-1 a while ago, but it's been kind of slow getting through this. 5-3, 5-4, that assignment's what I told you guys to hold off on. At least hold off on submitting it until we do these notes today. So, let's talk about these notes today. If you knew how to do all of it, sweet, good for you. So we did all of this yesterday, and we got down to here, right? And we had one set of those 3 values, right? Can you help verify or not? Because I'm trying to remember. And Caleb? And what was this really telling us? Why did we show this? Derek? Sunday night at midnight. It might be Monday night, actually. So check Schoology. And I can even pull up Schoology as long as it's not grades. I think I'm on my school. So, guys, just like you are taking a class on Schoology, just to show you, I'm also taking a class on Schoology. So this is one of my written responses. This is Mr. Combs, our Spanish teacher. That's his response to that discussion board. So know that, just like you guys are taking classes on Schoology, so are we. I saved that in my Google Sheets, don't worry. My advice is if you're ever typing something and you don't know if the website that you're on will save it, type it in a Google Doc, copy, paste it over. So if I look at these assignments, 5-1, 5... Hey, Derek. I'm trying to say that and you're interrupting me. So right here on the right side of your Schoology page, every time you log in, you can see all of the upcoming assignments. These are just there. That don't worry about those. Those are going to change dates, and we probably won't do them on Schoology. I just have them there as placeholders. But these are what you want to care about. So Monday at midnight, 5-1, 5-2 should be done. So you still have Monday to work with me in class if you want. Tuesday by midnight, 5-3, 5-4 should be done and submitted, above 80%. And guys, I'm going to start putting things in MAP more quickly than we had been because MAP is up and running. We're up and rolling. And then by Thursday at midnight, you should have the 5-5, 5-6 done. Notice there's a 2-day jump there. So I'm giving you an extra time with that because we'll be doing 5-5 on Monday. We'll be doing that lesson.
Jeremiah Smith, please come to the office. Jeremiah Smith to the office, please.
So always knock it off. We don't do that here. Always check this right column for your due dates. And that's the quick way to get to the assignment. I can just click right here and get to the assignment. I don't have to go through the folders. Now, I don't want to click there because see people's grades, but if you're on Schoology, you can click right here to get to the assignments, or go over to your grades tab to look at all of your assignments together and look at all of your percentages, and then you can click to the assignments from there. So there's easy ways to jump to those assignments. So I need help making a positive 2 now, but we still can use negatives to make a positive. So I want to see 3 different divisions using the same P and Q, but they don't have to stay positive. This is kind of confusing, so I might show you what I'm talking about. I can do, let's make this easy, 4 divided by 2, and that'll give me 2, right? But I could also do a -4 divided by a -2 because a negative cancels out another negative. And we should all be writing this down in our notes, right? Then, this is where it gets really weird. If I did the opposite of a -4/2, what's the opposite of a negative? A positive, right? So, anytime there's two negatives involved in a multiplication division, they cancel each other out and become positive. They pair and become positive.
So it would just come out as 2.
Yeah, all of those would just come out to be 2. I'm going to clear those and shift up a little bit. So how do we get 0? Ooh, right?
You could do 12 divided by 0.
I can do 12 but wait. If I have 12 of something and I divide it to 0 people.
Would it be 0 divided by 12 then?
Ah, the 0 can never be the denominator. So we can do 0 divided by 12.
There's no such thing as -0, right?
There isn't. 0 has no sign. It's the lack of value. 0 actually doesn't actually exist. Because if you think about 0 of something, then it doesn't exist. I have 0 pizzas right now. So they don't exist. It's not a countable amount. So 0 is just kind of, there's a placeholder for us to reference when we have nothing. So it isn't positive, it isn't negative, it's just 0. So
So it would be 0 over -12.
yeah, even if 0 is divided by a negative number, it just comes out to be 0. Because if you have 0 of something, it doesn't matter how many you divide it to, it's 0. Yeah. Yeah, and I could change, so really I'm going to put 0 over, and then this is not the hashtag. This is the number or pound symbol. Sorry, my smartboard is disaligned, so I keep kind of drawing it wrong. It looks like a tic-tac-toe board, and yes, you guys call it the hashtag, but it's not. Well, it is now, but it's actually the number symbol or the pound sign. Now, what if I want to make a rational number? I want to make -2/3. It's in fraction form. Somebody else. Guys, I'm making the cards this weekend. I've got a whole list of what I'm doing this weekend. So be aware that on Monday, I just start calling on people at random. So it is better if you get used to participating now. So Brady doesn't just run this class. Yes, okay, Brady and Josh.
Wait, I just have a question.
Okay.
So is it, how do you get the negative, or
How do I come out with -2/3 being my answer? And to make it a little bit harder, let's not use the numbers 2 and 3. Let's use other numbers. Oh, give me that sour face. Casey? Ooh, I like it. How'd you get there? Yeah, so Casey tripled my numerator denominator, but you have a minor error. She's got it. What needs to happen over here to make my answer be negative? I could put a negative in front of it, or on top of it, or on the bottom. It doesn't matter where the negative is, it will come out to be the negative fraction. And now if I want a positive 1.5, all right, Brady.
Okay,
Sorry, Ellie.
3 divided by, 3 divided by 2.
Ellie, do you know another one? Using the same numbers, but we can throw some negatives in there to have fun. Ooh, the negative divided by the negative cancels out and makes the positive. And the last one, like we had up top, do you know how to say it correctly? Go ahead, Brady, if you think you do.
Wait.
The one that we had up there with the parentheses. We're going to make it that form.
Oh, wait. I forget what, you do the positive thing, but it's with the parentheses.
So if this isn't attached to a number, we say the opposite of -3/2. And the opposite of a negative becomes positive, gives me a positive answer value. Any questions? So we need to figure out 8 divided by some value equals -2. And this is actually an intro to solving equations. So when we have equations, what's the major rule? And we don't have to apply that here. We can figure it out because our number sense. But does anyone know the major rule when working with equations? And it's kind of the same as when we work with fractions. Sarah? So order of operations still, so I use that to help manipulate each side. So like if a side has parentheses, I have to do that. If there's multiplication, I have to do that. So I agree, we do use order of operations, but there's another one. How do we manipulate fractions? Like if I had the fraction 10 over 20 and I wanted to reduce it, what do? Yeah, Caroline? I have to divide or multiply the same on top and bottom. In an equation, I would have something like 5 plus x equals 10. And to solve it, and this is a very, very easy equation, to solve it, we actually use inverse operations. So since this is a positive 5, I would get rid of 5 on both sides and find out that x is actually 5. Check it. 5 plus 5 equals 10. We're good. So the rule with fractions, where what I do on top, I have to do on bottom, is the same with equations, but it's what I do on the left, I have to do on the right. So we're going to get to equations here in just a few chapters. I just wanted to introduce that since this is technically an equation because it has an equal sign and it has an expression on both sides. Now, when we look at these expressions, and this is working for our vocabulary, I want you to notate this is numerical or constant, you can say, because numbers are constant. And this side, what do we call letters that we don't know what they are yet? Ellie? Yeah, so these are two different expressions. We have a constant expression and a variable expression. Now, we could work through the math to solve this. We could set up a proportion. We could do all that. Or we could just think. 8 divided by something gives me 2, and the 2 has to be negative. What do I think first? What do I divide 8 by to get 2? Olivia? 4. But then think, what do I divide by to make a negative number? Olivia? Now I have a positive here, so I need a negative in the division. So if we went and thought about 8 divided by -4, there's one negative, so it does not cancel. It stays in the problem and becomes -2. Any questions on that?
In elementary school, the thing that where, but it would be switched to the addition side would be the other side, and the answer would be on the other side, and there would be a variable.
You're talking about equations?
Yeah.
Yeah, we're not there yet.
With that, I would have to show you.
So you're talking about another way to solve this?
No.
Okay, let's talk later, because I don't know that I'm going to get through all these notes. An elevator descends 1,000 feet in 8 seconds. I want you guys off, actually 8 seconds is a long time if you really think about it. I want you off to the side of here to notate this is a unit rate problem. And we are going to get into unit rates here later in the year. Actually very soon in the year. But we need to understand how division works before we can talk about unit rates. So when we talk about something descending, aside from I had a friend with the last name of Descender when I was a kid. He was a drum major at OSU. Pretty sweet. What do we use to represent descending? Caleb? A negative, right? So this is really going to be a negative 1,000 feet. And we can use the little apostrophe for our feet mark. In 8 seconds, so we know that's just 8 seconds. Express the movement of the elevator as a unit rate. So you could also underline, highlight, circle that, but I wanted you to have it notated off to the side to catch your eyes. So anytime we talk about a unit rate, can you guys think of any rates that you see out in the world? Zion? What do you mean? So I know how I can use pepperoni pizza as a rate, but a rate has to involve like the word per. Donatas. How many pepperonis do they guarantee on their pepperoni pizza? Did you say 18? Donatas has 100 pepperonis on every large pepperoni pizza. I know, like Domino's would probably have like 18. But Donatas is crazy. They edge to edge with pepperoni. Same thing with Massey's. Massey's guarantees the number of pepperoni on their pizza. But that would be 100 pepperonis per pizza. That could be a unit rate. Olivia? Miles per hour. And as you get your license, that becomes ever so important. I've had one speeding ticket. Avoid them. They're no fun. Ella? What? What do you mean? Like what per square unit? Yeah, but we would need some other rate first. But I agree. But what I was trying to get to, sorry, we got to start hurrying. Last one, Ellie. Seconds per minute. Yeah, that's actually a conversion rate. So that is a unit rate, but we use it to convert things. The big thing with rates is after your per should be your time. So after the per should be your time. And per, actually, if you have space to notate this, per is a code word for division. So we want to know how many feet it descends per second. So we want to figure out feet per second. How many feet? Some number of feet per 1 second. Every unit rate has to have a denominator of 1. So what we have is negative 1,000 over 8. Yeah, we just do the division. Or, because I know my denominator has to be a 1, to make 8 into a 1, we divide by 8, which is doing the division, essentially. It's just showing it in proportional relationships. So this becomes 1 second, and now we're going to label it 1,000 divided by 8. Break this up, guys. What is in 1,000? That would be really easy to divide by 8. 100. Fine? Not 100, Olivia. 800. So if I break up 1,000 to 800 plus 200, 800 divided by 8 will give me 100. So I'm going to think, okay, I know it's going to be 100 something. Then 200 divided by 8. Break that up into things I know. 80 would be another 10. 160 would be 20. Can I go another 80? No. How many more can I go? 40, which would be how many 8s? 5 of them. So we get 125 feet per second. Because this division we saw was 100 and then 25. We break up the division. Now, of course, you can reach for a calculator, but guys, these are not difficult numbers. Think of how we can make it easier. So, think about how long a second is. 1 Mississippi. You just dropped 125 feet.
That's weird.
So, if you've ridden like the Power Tower or any of those rides where it just drops you, this is probably a very fast elevator, but I forget what rate, and you could ask Kabilo this, I forget what rate you have to drop at to cancel out gravity. Like there's a certain rate that if you drop at, you will feel like you're floating because you are dropping the same speed that gravity's pulling you, so you're canceling out the forces. Caleb? Yeah. Was it Chicago?
No.
Okay. I was about to say, when we go to Chicago, we go to the Sears Tower, which is now called something else, but I will always call it the Sears Tower. We got to keep moving, guys. I'm sorry. I would love to take everyone's stories. Flip to the back, please. We have a new vocab word that I would like you to underline, circle, star, something to notate it. And I have a different way to remember this. If I look at 1 over 2 compared to its reciprocal, which is really 2 over 1, and then I have negative 2 over 3, its reciprocal is negative 3 over 2. Ellie, do you know how I'm going to tell you to remember this? Yeah, it's really, how do you know that? Nice. So when you think of reciprocal, think of refliprical. Because all we do is flip it. We don't change the sign. We don't do anything else. We just take the fraction and flip it. If it doesn't start in fraction form, make it fraction form. Your numerator becomes your denominator becomes your numerator, and does it matter where the negative is? No. So a lot of times we just throw the negative right out front. So instead of being on a number, it's just out front. So I have a negative fraction here, 7 over 21. What would be its reciprocal? Somebody new, if possible. Sarah, you're not new, but Reagan. Okay, Sarah. I know Leah. My bad. But fine, Sarah. We'll go back to you. You people that are not participating at all, I might put extra names of you in the card deck. So, Sarah, what would be the reciprocal of negative 7 21sts? Yeah, it would be negative 21 over 7. Or we could look at this and reduce it to begin with. So negative 7 over 21, we can actually look at negative 1/3. And this could actually be looked at as negative 3 over 1. So it depends on if you reduce first. If we don't reduce, that's our reciprocal. If we do reduce it to negative 1/3, then this is my reciprocal. And that is why I tell you guys you should have some highlighters to notate what relates to what. Ella?
So are we gonna, is that gonna be on the test, like, doing reciprocals?
Yeah, well, so we end up using it for multiplicative inverses. We're just not quite there yet, and we're gonna get there.
Then do you think it'd be important to reduce before we do it?
I would accept either. But my encouragement to make your life easier is always reduce if possible. So that's my encouragement. I'm not going to take points out because technically this is right. But so is this. So either of these are reciprocals for that value, and these are equivalent. Brady?
Okay, so I wanted to answer the next one.
Yeah, so when we talk about does 0 have a reciprocal, well, we have to start by thinking about 0 as a fraction. So Brady, when you think about 0 as a fraction,
Okay. So obviously a 0 can be the denominator.
so
So if zero
set it up. So you're jumping ahead. So if you think about 0 as a fraction,
so let's say 0 over 12.
okay, 0 over 12 would give me 0. So then,
But if you put the reciprocal, it would become 12 over 0, and that doesn't work.
it would become 12 over 0. Why doesn't that work?
Because the 0 can't be on the denominator because it doesn't work.
That doesn't make any sense. So no. And here's why. We end up using reciprocals to make 1. Because a number times its reciprocal, let me capture this really quick. A number times its reciprocal is 1. So if you think about taking a number and we make this number 0 times its reciprocal, which is its flip, and that would multiply to make 1, it doesn't make sense. It can't happen. It's physically impossible. So that's why 0 can't have a reciprocal. So another word for reciprocal, and we will get to this vocab word, but if you are trying to learn everything you can and absorb info like a sponge, reciprocals are also the multiplicative inverse. Those are also $5 words that can blow your parents away. sorry. Hold up. Don't. Hold on. I got ahead of myself. It's not just the reciprocal. My apologies. I want to correct this now. It's the negative reciprocal.
I don't even have one.
You don't have to write this right now if you don't want. But the negative reciprocal, so like the opposite reciprocal, because I haven't taught this for a year. I had to like say it and then realize I'd said it wrong. Multiplicative inverses always make negative 1. So because these make positive 1, if one of these became positive, then this would be a negative 1. Then it would be the multiplicative inverse. But I think we get there maybe next chapter.
So it's always -1?
The multiplicative inverse, it's up there, but you need negative reciprocal. But don't even worry, like, you don't have to worry about that yet. I just sometimes like to give you guys lots of information. Yeah, I have you guys for like a couple extra minutes today. So, when we talk about multiplication or division, we're really talking about the same thing. So, we don't like division. And you might like division. That's fine if you do. But division is a more complicated process than multiplication. Even when you compare long multiplication, the stack method, or array multiplication, which if you haven't seen array multiplication, it's on our Schoology page. Well, let's say we had a number like 325 times 47. That seems really hard, right? I guarantee we can do this without a calculator. So if you've never seen the array method, I would suggest writing this somewhere. You probably don't have space on your notes. But how this works then, I set up one number across the top, and I set up my other number across the side.
Oh, I think I've seen this. I don't remember.
So this is really 300. This is really 20. This is really 40. So we have 325 and 47. Any confusion on how I set that up?
No.
All I did was spread out my numbers. I broke them apart. Can I do 3 times 4?
Yeah.
That's real easy. 12, right? Then I put on that many zeros. So 12,000. Can I do 2 times 4? Yeah, 8, right? And then I put on that many zeros. Can I do 5 times 4? And you guys can just shout it out at this point. 20,
Accidentally wrote.
and I put on that many zeros. 20 times 40 would give me 800. Then I do 300 times 7. So do 3 times 7 to 21, then put your zeros on. 20 times 7 and 5 times 7. If we add all these up, 12,000 plus another 1,000 would be 13,000. 14, 15,000. 240, 275, 15,275. Once I add all these numbers up, I'll check it.
You did it in your head like that?
I've added numbers for a very long time. I just have more experience than you guys. It's not that I'm better, it's that I have more experience and more practice. 15,275. Without a calculator, what, that took us maybe a minute? Yeah, but I used it to verify. To prove to you that we did this correctly. Casey.
Okay, 2 questions. First,
2 answers.
is it verify or verify? Are they 2 different words?
Verify, like verify.
Next question. Do you know math teachers that can't do math?
I mean, my first year here even, like, I am faster now than I was my first year teaching. It's just experience. The more that I do it standing up in front of a group without a calculator, the better I get. So the more that when you're doing math at home, you try to work without a calculator instead of immediately reaching for it, the better you're going to get at doing this math. Come on, smartboard. I want to capture this array method. It doesn't really have to do with the lesson, but it's worth it. There you are. Well, today you're first so that I can get it uploaded. I'm recording this. Dividing by 3. Again, let's think of our pizza. Dividing the pizza in 3 would make what size of slices? Right? Thirds. So dividing by 3 is really multiplying by a third. So if I want to change division into multiplication, I just use the reciprocal, because multiplication and division are reciprocal operations. So we can change the operation as long as we use the reciprocal of the value. This process that many of you may remember, Ellie? Huh? So the process that we're actually doing here of keeping the first value, this stays the same. Casey? Keep, change, flip. We keep the first value, we change from division to multiplication, and we flip
Oh no.
that second value. So keep, change, flip.
That was my teacher in elementary school favorite motto.
Now some people use keep, change. I don't like that because you don't then it makes you wonder, well, change and change, what am I doing? Change and then flip is easier to remember. Bree?
You should play the keep change flip rap song.
Okay, we don't have time today. Maybe Monday. So we want to change this into multiplication. So I want you guys above these. I'm going to zoom in so I have more space to write. Above these, I want you to write K, C, and then F. And I like to write my C a little bit lower. No. So then drop down. In math, it's almost always easiest to work vertically. Drop down your 9/2 and it stays the same. Then we change my division to multiplication. And then we flip my fraction from 7/5 to 5/7. Then, how do I multiply? There are 2 words that remind us how we multiply. It's a fairly easy process. Yes or no? Josh?
Across.
Yeah, straight across. So be careful, because sometimes across people think diagonally. So we multiply straight across or straight through. Bring the negative with you, because there's only one negative in the problem. 9 times 5 is?
45.
Anybody? Thank you. 45. 2 times 7? 14. Do they have a common denominator, or a common factor they could be divided by? 2 would work for 14, not 45. 3 would work neither. Well, 3 would work for 45, but not for 14. 4, no. 5, no. 6, no. 7, no. 8, no.
Not possible.
So this could be left like this, or if we turn it into the mixed number form, how many 14s can fit in a 45? Ooh, not quite. 3. Think of it like 15. It's very close to 15. 15, 30, 45. But I wasn't at 15, I was at 14. So I actually, instead of having all of 45, I have 3 left over. So either of these would be your correct form of that answer. Questions? Now this next problem uses what I nicknamed the DIRT formula, but it's not dirt as in outside getting dirty. It's DERT. So I don't even know why these memes use like derp or those sorts of things, but it's dirt. So up here, right, if you have, and you might not have space, you could write over here, D equals R times T. The E is for the equals. And that represents,
Distance equals rate times time.
yeah, distance equals rate times time. So however fast you're going, for however long you do it, tells you how far you go. So this is a manipulation of our distance formula. My rate here is -4/5. So the equation D equals -4/5 T gives the depth D. So their distance is rating depth, but it's still distance, in miles of a submarine at T hours. So it is diving 4/5 of a mile every hour. So this 4/5 is our unit rate. How long does it take the submarine to reach 2 2/3 miles below sea level? Now this is where that equation work comes into play. If we start, well, what would this 2 2/3 miles be? If that's how far they're trying to go, what part of that equation would that be? Ella? The distance. Now, I don't like mixed numbers. That's a personal preference of mine. I always immediately change mixed numbers into impropers. 2 times 3 gives me 6, plus 2 gives me 8/3. So I'm going to set up my equation that was d equals negative 4/5 t, but now my d, I can plug in 8/3 equals negative 4/5 times t. But actually, I'm going to flip this around a tiny bit. Multiplication's commutative. I'd rather have my fraction over here, and I will show you why in just a moment. We said that reciprocals, when you multiply by a reciprocal, it turns into what? When you multiply a value by its reciprocal, it turns into, if you don't remember, it's on your notes, Caleb. Well, that's the negative reciprocal. So we'll get there when we want to make -1, and that's got a different use for it. But just the reciprocal, if you look at the multiplications up higher on your notes, right here, this and that, when you multiply by the reciprocal, what do you make, anyone? You make 1. So, if we here, there we go. If we here want to get rid of this fraction, because what we're trying to do is solve for t. We want to get t by itself. So what we can do is if I turn this into 1, what does multiplication by 1 do? Casey? Doesn't do anything. Multiplication by 1 doesn't change anything. So I could multiply over here by 5/4, and it has to be negative since this was negative. It's got to stay negative. So I'm going to clean that up a little bit. Times negative 5/4. These will all cancel. This just becomes 1. But I have to do it on this side also. Negative 5/4. So now this becomes negative 5 times 8 gives me a negative 40. 4 times 3 gives me 12. That would equal what on the right side? Brady?
So would it be? Wait. Oh yeah. Would it be? So it would be 3.
Oh, I'm not trying to solve this yet.
Oh.
So over on the right-hand side, t now is multiplied by these guys. Negative 4 times negative 5 gives me 20. And on the bottom, I get 20. 20 divided by 20 is 1. So this really becomes t times 1, and the times 1 does nothing. So t would just equal, 3, and then you have 4 left over, so it's 3 1/3 hours. So does it make sense that this is a negative 3 3/3 hours?
No.
So that's talking about like time back. So really we could say it would take 3 3/3 hours to dive that far.
So we just crossed out the negative.
Well, so it's talking about how long ago were we at where we were. So if we were to express it, we'd say it took us 3 1/3 hours. We're 3 hours 20 minutes. All right, thank you guys. We will solve that last got it on Monday if people would like to. Aside from that, have a wonderful weekend. Let me know if you need help on anything.
Mr. Hudson.
Yes, sir.
The only thing I just need help on
Is your what?
Is there any?
Yeah. Do you have AO today?
Yes, I do.
That'd be sweet. I have both AOs today, so we can work during then if you want.